inverse functions. Here we go. First thing I'm going to do is write. Are y'all listening for them? Thank you. I got a relation here that has the ordered pair 2, 5, 3, 6. It's a 6, 4, 8, and 8, 7. Alright, so the directions for this, that looks rough. The directions for this relation, and a relation is just a fancy way of saying a set of ordered pairs. So there we got a bunch of ordered pairs up there that makes a relation. The directions for this say, decide whether the function is 1 to 1. If it is, find its inverse. Okay, so 1 to 1 is a new term that we're going to be discussing today. To decide if something's 1 to 1, there's several different ways we can decide, and it depends on how the information is given to you. This one's given to us as a set of ordered pair. So all I'm going to look for in this is that each x value can correspond to only one y value. And each y value can correspond to only one x value. Things that help me to decide this, I'm going to make what we called in middle school a mapping. I'm going to put all my x's in the x bag, and I'm going to put all my y's in the y bag, and I'm going to hook them up. This x goes with that y. I'm going to draw an arrow to hook them up. So my first x that I have up there in the ordered pair is a 2, and it hooks up to the 5 in the y. Okay, this is called a mapping. That's what I'm mapping out here. Then I've got an x of 3 in the next ordered pair, right? And it goes to 6. Then I got a 4, and it hooks up with a y that's 8. Then I got an x of 8, and it hooks up with a y that's 7. So, is there anything in either one of those sacks there, the x sack or the y sack, either one of them, is there any number there that's got 2 or more arrows, that's got more than one arrow? Is anything being double dipped out of that?
No.
No.
Yes.
So, no. Everything only has one arrow. So, is that 1 to 1? Yes. If anything had used more than one number, and if it had required more than one arrow, then it would be no, it's not 1 to 1. But yes, this one is.
Like if the ordered pair, if there was a 2 in the x spot twice?
Uh-huh.
Okay.
Uh-huh. Now, it said if it was 1 to 1 to write its inverse. Okay? So the inverse, what do you think common sense-wise you'll do to write the inverse of an ordered pair? Close. Just flip it. Very good. So what was 2, 5 is now going to be 5, 2. Okay, what was 3, 6, the inverse will be 6, 3. What was 4, 8, the inverse will be 8, 4. See what Rachel said we're doing there? What was 8, 7, the inverse will be 7, 8. So there's the inverse written in a column style over there on the left. Or that's the right, over there on the right.
Perfect.
Pretty easy. Inverse, when it's an ordered pair, you just split the order. Y comes first instead of X. That's it. Okay, I want to show you one like Grace was talking about where it's not a 1-to-1 function, so we can see what one of those looks like, and then we'll move on to the next phase. Okay?
Wait, what happened with just now? With the,
That was the inverse. We just flipped the ordered pair.
why'd you do that?
Because the direction said write the inverse.
Oh, okay.
That's what you do. You just flip the X and the Y. Alright. Can I move pages, or are you still copying that, Grace?
I got it.
She got it. Here I got the order, the relation that has 0, 3, negative 1, 2, and 1, 3. Now, some of y'all will already be able to answer this without drawing the mapping, and that's great. I'm going to draw it. The question's the same. Determine whether that function is 1 to 1. If it is, write the inverse. So I'm going to make a bag to put my x's in, and I'm going to make a bag to put my y's in. Okay, so the first ordered pair that I have has an x of 0, and it goes to a y of 3. The second ordered pair that I have has an x of negative 1, and it goes to a y of 2. The third ordered pair that I have has an x of 1, and it goes to a y of 3. I already have a 3 in that y bag, so I don't get to put another one. So 1 goes up there to that 3. Now when I ask you, is there any number there that's got a double arrow on it? Yeah, the 3 is getting reused. So that is not 1 to 1. All that means for you when it's not 1 to 1 is that you don't have to write the inverse. So you're off the hook, not 1 to 1. You're done with that. Okay, now basically all the stuff that we're going to be doing today is the same thing but in different forms. That one was in the form of ordered pair. So now we're going to look at what to do when it's in the form of a graph. Okay? Everybody all right? Alright, let me draw us a couple of graphs to look at. We'll look at that one, and then we'll look at that one. That's an arrow. Alright, so I got two different problems for you in those two graphs there. The directions say use the horizontal line test to determine whether the graph is a one-to-one function. We did a vertical line test when we were just testing if things were functions or not. Okay, now I'm already telling you this is a function. I want to know more specifically, is it a one-to-one function? So I used the horizontal line test. So I had to make myself a note when I was working through this earlier. So I'm going to say to do a horizontal line test when I'm checking for a one-to-one on a graph. Okay, so a horizontal line test will answer you a one-to-one on a graph. It's just like a vertical line test, except your line is horizontal. Duh. So I'm going to get my horizontal line, and I'm going to draw it through number 1 up there. Did that horizontal line touch that graph more than one time?
Yes.
Yes, so that failed because it touched there and there. So that parabola is not one-to-one. Okay? What about on the other graph? What do you think on that graph where I just drew those horizontal lines through it? And we could say if I started on the bottom, touch that one once, then move up, touch that one once. Up here's where it gets fishy. How many times is it touching there?
1.
1. Very good, Kaylee. What we have to understand about a lot of our graphs is that sometimes they appear to level off, but we know from when we labeled domain and range on stuff that that thing is going to keep inching upwards, right? So it's not going to hit the horizontal line more than once. So yes, that one is one-to-one. Okay? So we can decide based on a set of ordered pair. We can decide based on some graphs. But the next thing, maybe. Oh, we got 2 more. Next thing we got to look at is the equations. And this is where you have most of the algebra work to do, is when they give you the equation. They got what we need? Alright. This first equation I've got says f of x equals 3x minus 4. Okay, the directions for this say decide whether the equation is a one-to-one function. If it is, write the equation for the inverse. So the first thing we got to do is decide whether it's one-to-one, and we're going to do that just based on past knowledge or using our graphing calculator if we don't have any past knowledge. What I'm talking about, I know what that forms the graph of. Most of y'all do also. 3x minus 4 makes what kind of graph? Very good. Makes a line. It's got a positive slope. So I know that that would look something like that if I were to graph that. Right? So I know that that would pass the horizontal test. It is a one-to-one function, right? Okay. If you're not sure, then you plug it in your calculator and check it on there. See if it would pass the horizontal test or not. But it would pass the horizontal line test, so it is one-to-one, so we got to write the inverse. When it's an equation, step 1 in writing the inverse is to switch the variables. Y'all are going to wish y'all knew how to do this on the test. V-A-R-I-A-B-E-L-S. I don't know. Switch the variables. F of x is the same as which variable?
Y.
Y. Very good. So I'm going to switch it to an x. equals 3. Switch that x to a y. Look at what we did. We just flip-flopped the x and the y. That was step 1. Switch the variables. Flip-flop the x and the y. Step 2, and sometimes step 2 has many steps inside it. Step 2 is to solve your new equation for y. So this new equation that we have written over there, we got to get the y all by itself. So what would be our first goal? What would be our first action to get that y all by itself?
Add 4.
Good, good. So we're adding that 4. So that'll get us x plus 4 equals 3y. And then divide by 3. And you can divide them individually. I'm just going to leave it all over 3. But you could write them each individually over 3 if you wanted to. X over 3 plus 4/3. Okay, so step 1 was switch the variables. Step 2 was solve for y. Step 3, the last step, is kind of a nitpicky one, but it is still a step. We have to write it in inverse notation. The symbol for inverse is a -1 power. So I'm going to say f to the -1x. Just now I'm rewriting it. X plus 4 over 3. That anytime you see that f to the -1, you've seen that before, maybe didn't know what it meant, that just means inverse. So switch the variables, solve for y, write it in fancy inverse notation. Yes, it is. We got just a little bit more, but it's easier than that. That would be the hardest part of today. Alright, let's do one more of those, then we'll look at the last thing. This one says f of x equals x cubed plus 1. Directions are the same as the last one. Decide whether it's 1 to 1. If it is, find the equation of the inverse. Alright, so to decide whether it's 1 to 1, we got to know what that graph would look like. So this might be a time when you grab your graphing calculator and graph it real fast and just look and see. Okay? So I've got a couple that are doing that, so I'll hit pause for a second while a couple get a graph of that. I did it this morning, so I remember what it looks like, but I want you to look at it too. You know, your degree is odd, so it's going in opposite directions, and it's positive, so it's going uphill.
What about in the very
Hit zoom 6. What about in the what, sweetie?
in the very middle?
Oh, here we go.
Yeah, that's one thing I'm going to bring up to y'all about. We got to decide. You're right. Here's draw.
Would that just be like the origin? Maybe. Oh, that's in the text, but
Right. It's not. It would be if you're talking about symmetry, that it would fold like diagonal.
Oh, we're bueno.
Yeah. All right.
I don't know if that was just a single point.
Yeah. All right. I've been putting Grace on hold, waiting on the rest of y'all because she brings up the question that everybody's going to ask about this. Those of y'all that graphed, did y'all get something similar to that?
Bueno.
Okay, good. If we start looking at a horizontal line test, touched it one time, we're good, right? Touched it one time, we're good. Do you see on here where people will not be so confident?
Yes.
Well, if I drew one right through the middle, kind of iffy there, right? Because it kind of looks like that graph levels out in there. So what I would need to do now is go to my table. So hit second graph and let's go look at our table.
Bueno.
And that, we're moving up to that, so that's a y value. So I want to look in the y values and see if I got any numbers in there that are repeating anywhere. Okay, Grace says no. Everybody agree? So yes, that would be a 1-to-1 function. These calculators, as far as resolution and pixels and all that's concerned, are pretty much archaic, and they don't give you a real good picture on that. You hungry? You hungry? Oh. Oh, I see what you're doing now. Alright, so yes, it's 1-to-1, so we got to write the inverse. What was step 1 on writing the inverse? Switch the variables. Very good, Caitlin. So we got x. Now keep the exponents where they were. That third power was over there on the right side, so keep it over there on the right side. Only the actual variable switched. Okay, so Caitlin got us there. Now, after we switch the variables, what do we need to do?
Solve.
Very good. We're solving for y. How do we start that? Good, Chase. How do we start solving for y?
Take the one to the other side.
I like it. X minus 1 is y cubed. Hey, stop it. What do I do now? Good. Undo that cube root. So y is the cube root of x minus 1. I'm good on that, but that's not the technical correct notation. So that's our third step, to use our fancy notation and say the inverse of x is the cube root of x minus 1. Winner, winner, chicken dinner. All right, check this one out before we go to the last thing. I got f of x is x minus 3, the quantity squared. Here's what the directions say, same as they have. Decide whether the equation defines a one-to-one function. If so, find the equation of the inverse. So is that a one-to-one function?
No.
Very good. Zane is quick and correct, and y'all should all be quick and correct on that. Because what kind of graph does anything squared make? Yep, it's a U or a parabola. In this case, our x is positive, so it's going to open like that. And that would fail the horizontal line test. So all I would have to write on that is not 1-to-1. They said if it's not 1-to-1, you don't have to find the inverse. So, hey, not 1-to-1. Hit the road, Jack. Don't you come back no more, no more, no more. Alright, so the last one that we got to look at is find the inverse on a graph. So I got to write on the graph paper up there. Okay, so we got a graph that looks something like that. The directions say use the given graph to graph the inverse. Here's what we got to know about an inverse, other than just the ordered pair switch. So you could do that, and I tried to be intentional about these ordered pair and get them on good points. So you could use that. You could say, well, this one is -1, 1. So like we said earlier, its inverse would be 1, -1, right? That's one plan of attack, and you could do that. Other thing, when you're finding an inverse, the inverse is the reflection over the line y equals x. Okay, so there's the line y equals x. That line, y equals x, has a b of 0 and a slope of 1. Rise 1, run 1, rise 1, run 1, rise 1, run 1. All reflections, inverses, reflect over that line. So while we could flip these points and regraph them, other thing to do would be some simple counting. Okay, I could say, well, to get from this one to my line, I go there, so I need to go there on the other side. Right?
So you would just switch them.
So this one now is 1, -1.
And this one would be 2, 0.
So the next one is at 0, 2. So Grace says would be at 2, 0. Let's see how that works on my little dotted line drawing trick. Does that still hold true? I would go to there. So I continue it. Yep, Grace was right.
So is it like what we did at the very beginning?
Yes. We
To write
flipped
the
those.
inverse,
Yes.
do something.
Yes. So on this last one, that one was at 1, 1, 2, 3, 1, 3. So I'm going to go 1, 2, 3, 1. So I had to go there, and then I went there. Now, when you draw it, be careful of how you're drawing it, because just those 3 dots alone look to be linear, but this thing's certainly not linear, right? It approaches the x-axis. So what do you think this one's going to approach?
Why?
The y-axis. Y'all are smart, smart, smart. And then away he goes. I said that kind of reminded me of a ladder or something first period. They start talking about shoes. I don't see a shoe in that. I don't know. Maybe those are the laces. I don't know.
I can see that.
You do?
I see when you said the laces, at first I was like,
Oops, sorry.
Me, not so much. All right, where we head tomorrow is exponential functions. Get a little bit more fun and a little bit tougher also. Okay, you are fixing to have an exit one real quick. It's an easy one. They got what we need on this graph, and I'll just jot it up there for you. All right, directions here say, is it 1 to 1? If so, give the inverse. Okay, I'm hitting the question in your classroom now. Is that 1 to 1, yes or no? If yes, you got to tell the inverse. All right, should be there for you.